you're looking at is a knitting needle. And I happen to have in my crew preference a couple of knitting needles. And not that we have a lot of time to do knitting up here, but there's some other neat things you could do with them. So here I have a piece of paper, and I rub the knitting needle with a piece of paper. And now I'm going to take a syringe with a little Teflon cannula. I'm going to squirt drops of water out, and look what happens when those drops of water get close to that charged knitting needle. So this is like a little satellite going around a cylindrical-shaped planet, except the physics here is a little bit different. It's not about gravitation. It's about charge forces, and of course, charges can exert a potential field, as we call it, so it can exert a force at a distance with no tangible connection. And so you have a charged drop that was ejected from the Teflon-tipped syringe, and then you have the charged knitting needle, and they're going to be attracted if they're opposite charges, but because the drop has some velocity to it, it's orbiting around the knitting needle. Now this knitting needle happens to be a little different than when we started out. This knitting needle is made out of Teflon, and Teflon has some really neat static charging properties when you rub it, and I figured it'd be good to have a Teflon knitting needle when you're on station. And here we have some little tiny droplets. They kind of remind me of flies on a picnic out in Houston. And these droplets, the bigger ones that you're seeing there, are about 6 to 7 millimeters. That Teflon rod is about 6.5 millimeters in diameter. And here you see a bunch of little tiny droplets, and they're making spirals, and they go down the cylinder for a while, and then they'll reverse their direction and spiral back. Now, if you look closely up in the upper right-hand corner, you'll see the injection nozzle from the syringe, but you also see that I have a second knitting needle. And that knitting needle is made out of nylon. And so you can rub the nylon, you can rub the Teflon, and there's some interesting charge properties that happen between Teflon and nylon. And I found that it's useful to have these when you want to put a charge on a droplet so it will orbit your knitting needle. And of course, once you set up a knitting needle like this, you start to play with the water droplets. You just can't have too much video like this. It's so much fun to watch these little droplets, and notice as they get closer and closer to the knitting needle, their orbits go faster and faster. And the further away from the knitting needle, the slower the orbit. The closer to the knitting needle, the faster the orbit. And that's the same thing with the orbital mechanics when you have a satellite around a planet. And again, the physics is different. A satellite's orbiting planets is gravitational potentials and gravitational forces. And this is static electric potentials and static electric forces. It's an analogous rationale to why we do surface tension experiments up here. Surface tension is a very weak force, and gravity overpowers it. And when you go in a weightless environment, you effectively remove the gravitational forces, and now you can look at unadulterated surface tension physics. I'd like to leave now with a question for students or anyone else that might be watching this. And that's to try to figure out, why do I have a Teflon knitting needle and why do I have a nylon knitting needle, and why I use the knitting needles the way I did.
Well, that was just way cool, Don. We were really enjoying that.